Alright, so welcome back to the channel everybody. So this is part 2 of the power project, and today we're going to start building. It's about back at 6 o'clock in the evening here, just things have cooled down now, so it's a bit easier to do things. So the first thing I'm going to do is prepare the ground for the solar panels. So what I'm planning on doing is I'll tear back all the weeds. I'll level off where these concrete blocks are going to go, where I'm going to use as anchors for the solar panel, and then I'm going to put down some weed fabric and then fix the panels to these blocks, and a couple of stilts for the back end. So the panels here in Cyprus, the optimum angle for the panels is 30 degrees, so I'll measure up all that and fit in the area. So here we go, let's get things going, and I'll catch up with you in a bit. Alright, so first stage is done. I've cleared all the way the weeds. I've put down the anchor blocks. I've levelled them off, and I'm not too worried about the elevation of the back box because I can adjust that with the brackets for the panels. And then I put the weed control fabric down. I've got 3 layers of weed control fabric, and then I put the blocks back on top, and now it's a case of going making some brackets for the panels and getting them bolted onto the blocks. So I'll catch you in a bit. Alright, so good morning all. You join us the next morning. I didn't get up as early as I was planning to because I ended up doing a live stream last night for 3 hours or something until about 2:30 in the morning, so I had no desire to get out of my bed this morning. So where did we get to last night? So I kicked off a build around about 6 o'clock once it was cooler in the evening, and cleared away all the dirt as we saw in the earlier part. Pulled out all the big weeds, put down 3 layers of weed control sheet, positioned the blocks, and I've got my straight edge here across all the front, and then I fabricated these brackets. So I just took some metal hardware and bent it to shape to hook around the bottom of the solar panels, and that will hold them in place. And then I'll just bend these back slightly to get them into a decent angle for taking the panels once I put them in the final position. So the next step is to get the panels and the frame for the other side built, and to get the elevation of the panels to 30 degrees, and we'll take it from there. So we'll catch you in a bit. Alright, so we've had a busy hot morning, and we've managed to get the solar panels mounted on a frame and bolted to, or the frame bolted to the concrete blocks. And next time I mix up some cement for the next pier, I'll put it along the front of the driveway and anchor the blocks to the driveway, but it's not going anywhere at the moment. So we'll take a look at what we've got. Alright, so here's the panels, and you can see the frame we've got mounted on here and all secured down onto the blocks. And looking from the front, there we can see the 2 380 watt solar panels. So all done. So the next thing to do is get the batteries mounted underneath the observatory, and that's what these blocks are for. We're just going to raise them off the ground and then lift them into place, and they'll be going in under there as we said previously. We'll do some wrestling with these. I think they're around about, the batteries are about 50 kilos each or something, and it's an awkward space, so we'll see how we get on. Alright, so I'll catch you in a bit. Alright, so I've just put the batteries in place, so we'll take a look. Here's what we've got. So I've put the concrete blocks, some thick planks which was left over from the joists of the observatory decking, and I've put the 2 batteries there side by side, and straight up above the right hand side of the batteries is the access up into the power bay of the observatory. So what I'll probably do now is I'll probably put a board across here between these 2 posts, and that will allow me to put the battery isolator and the main fuse off the positive. And that's where we are just now. Alright, so I think next we'll be looking at the internal power, where I'm going to put all the equipment inside. Alright, so where are we up to? What I'm planning on doing now is I'm going to prepare this area for starting to mount equipment, and I'll take out this is one of the shelf units from the next dome that I've just got sat on the floor. It closes up the floor. I'm going to take that out of the way. I'm going to move the extension rail round. I'm going to drop off the two extension blocks, and I'm looking at potentially putting another board, a wooden board on the left hand side and another board on the right hand side, with a view to putting the Solar MPPT input on this side and the battery balancer on this side, and then keep this main back panel for the inverter and the DC to DC converter and the charge blocks, or the distribution blocks. But I'll strip it all down first, get some boards mounted, and then I can work out the placement of all the various devices. I took a measurement of effectively the space available and laid out the equipment on my floor in my office, just to see what sort of space I had to play with. And then, depending on the depth of the equipment, particularly the inverter, I think that's the tallest piece of equipment, I'll potentially, as I said in I think it was in part one maybe, put another panel at the front for doing all the distribution of the individual circuits on the DC side of things. But that's down the road. Let's just get all the solar equipment mounted first, and the DC to AC inverter. Alright, so I'm going to crack on with that now, and we'll catch you in a bit. Alright, so now we've got the equipment mounted. So after installing the wood at either side, I placed out all the equipment, and the way I've broken it down is everything on the left here is for the solar power MPPT, the battery balancer, and the Smart Protect for the charge circuit, and then everything on the back plane is for the loads off the battery. So we've got the Smart Protect for the main load system, the master shunt monitor. We've got the two distribution boards, a fuse rail, the Phoenix inverter, which is the 24 volt to 240 volt AC inverter, and then we've got the DC to DC for the 24 to 12 volt converter for supplying all the DC loads. And then coming out of the inverter, I got myself a Shulco connector and hooked it up to 4 outlets, just using some 3-core 2.5mm square cable, and that will give me the basis of the system to get going. I'm just waiting for some crimps and a crimping tool coming, and I'll be able to then get installing all the cabling. So you can maybe see in the layout as well, I've also left gaps for the phase 2, phase 3 and phase 4 as I had on the drawing. So over here we've got the gap left for the phase 2 for an additional 12 volt DC to DC charger, same as one of these. And then here I've left the space for the phase 3, which was the option to do a second charger for the shutter battery. And then up here on the left I've left room for the Servo GX unit, should I want to install that and add remote monitoring into the system through the Victron remote monitoring cloud service. So that's where we're up to now. As I say, I just need to wait for crimps coming, so that's going to be a few days I think, so I'll have to find something else to do in the meantime. So we'll catch you in a bit. Alright, welcome back everybody. You join me back in the dome. The last couple of days I was waiting for some parts coming, cable crimps, crimping tool for the heavy duty cable, and a few other minor things, and then I had to go and get some cable this morning to do the connection between the PV panels and the observatory. So that's all the wiring done now. So let's take a quick look at what we've been up to. Alright, so here we can see we've got the MPPT charge controller with the cables coming in off the solar panels, and we've got the battery balancer with the cable going down to the two batteries, and then we've got the smart battery protect going from the charge controller down to the batteries. And then up on this side we've got the power coming in off the batteries, through the smart battery protect, through the distribution boards, through the fuses, into the inverter to give me the 240 volts, which goes off to the sockets. And then underneath we've got the 24 to 12 volt DC to DC power supply, and then all the negatives come back through the smart shunt and heads off back down to the battery. So let's head off downstairs underneath the observatory now, and we can see what we've got to still connect up down there. Alright, so here we are underneath the observatory. Obviously I didn't connect anything up to the batteries while I was doing all the wiring, just in case I accidentally dropped a tool or shorted something together. So all the cables coming down from the power bay in the observatory, and we've got the two negatives for going onto the batteries. Now I've actually turned the batteries around to bring all the terminals at this side, with all the cables being in underneath the observatory rather than exposed out to the outer edge of the observatory. So we've got the two battery cables coming onto the negatives for the battery. I've got the charge circuit isolator, and we've got the main power off the battery DC isolator, and then we've got the two fuses, 150 amp fuse for all the DC loads, and the 40 amp fuse for the charge circuit. Then what we've also got is the two cables that will come off for all the DC loads. They'll go onto the positive, and we've got the charge controller supply to the batteries that also goes onto the positive. Above here we've got the battery balancer inline fuses. So one of these goes to ground, one of them goes to midpoint in the battery pair, and one of them goes to the positive. And then in the middle here we've got the two smart battery sensors for monitoring the individual battery voltage and temperature. So there's one of these goes on to the positive and negative of each battery. And then we've got the smart shunt is doing its monitoring of the batteries as well. So one of these goes to the positive of the battery series, and then the other one goes to the midpoint of the two batteries, and that allows it to monitor the two battery voltages. And then also we've got a couple of battery interconnects that I've made up just to bridge the two 12 volt batteries together to give me a 24 volt system. So obviously we're in a position now that we can start powering up, and there's a sequence I've got to go through that just to make sure everything goes smoothly. And the battery power supply, sorry, the solar panels, I've still got them covered up at the moment, just while I was working on the wiring. So let's take a quick look over there now. Alright, so here we are at the panels. We've got the two panels, and they're actually connected in series. I've got still some tidying up to do for the wiring, but I need to get some clips and everything. And then I've put in this breaker box, so I've got a double pole isolator and two 16 amp fuses, one for each of the panels. So the the panels are connected in series, and these are just temporary. I do need to get proper full rated DC breakers. These aren't quite up to the full spec of the system that I've got here, but that's all I could get my hands on short term, just to get me up and testing. And then I've got a big thick blanket over the panels just while I was doing all the wiring, and even with that blanket over the panels, I was getting 77 volts and half an amp with the panels fully covered. So it's a good job I covered them over. And then lastly, we've just got both the panels are earthed, and that goes back to a central earth point that I've put underneath the observatory. So let's take a quick look over at that now. The other thing that I've done is all the way from the panels down through the dirt here, underneath the AstroTurf at the imaging rigs, and then coming back into here, I trenched the cable just to give it a bit of protection from the heat. It's dead ground, so there's nothing there, very stony as well, so there's not much hassle with it there, but it's just to protect it from the heat. And then lastly, here at the batteries, I've also driven a big metre long earth rod into the ground, and that's acting as a central earth for the DC system and for the 240 volt inverter, which needs a ground earth as well. And that's all the wiring done. So next up is obviously, as I say, to go and start connecting everything up, and I'll go and crack on with that once I've gone and taken a break, because I've been outside all day yesterday, today, and I'm absolutely plotting. So we'll catch you in a bit. Alright, so you join me back here under the dome, and yesterday evening, or yesterday throughout the day, I completed terminating all the connections and setting up the equipment, and the system's now operational. It's about 7 AM here the next morning, and I'm just waiting for the sun to start coming up onto the panels. The panels are active, and there is about 40 watts coming in off the panels at the moment, obviously with no sun on them. So yesterday, to bring the system online, I went through a particular sequence to make sure I could see all the individual devices and make sure everything was operating correctly, and I didn't have any shorts or anything in the system, rather than just connect everything up and then just turn everything on and just hope for the best. So for the sequence yesterday, the first thing I did was I connected up the lower battery. So the battery that's connected to the system negative is the lower battery, and then the system that's connected to the system positive is the upper battery, and obviously then the midpoint connection between the two batteries. So I connected up the negative, as I said, and then all the terminals that went on there were connected. So that includes the lower smart battery sense and the battery balancer negative, and then I held on the lower battery sense onto the positive terminal just with a finger, and that allowed me to connect up the mobile device to the Bluetooth of the battery sense and do all its firmware updates and set the pin and everything on there. I then connected up the then I connected all the remaining terminals onto the midpoint connection on the lower battery, and left the upper battery negative at this point just floating. I then connected up all the positive terminals onto the upper battery, and again with the upper battery sense I just held on the negative terminal for it, and that allowed me to then configure its Bluetooth connection to the device and do its firmware updates, etc. After that was done, I then connected up the midpoint so that all the battery connections were connected, and this allowed me then to configure the main load shunt, because it had sufficient power from its connections on the batteries and the system negative, and that allowed me then to turn on the solar panel isolators, and that allowed me to configure the MPPT charge controller on the system. After doing that, I then turned on the isolator for the PV charge control, and that put some power through onto the charger circuit shunt protect, or the battery protect, and that allowed that to then be configured and connected up to the devices. And then I put on the main isolator for the load system, and that allowed the load circuit battery protect to be connected up and working correctly. And after doing that, I went in and checked all the configuration, make sure the system set was 24 volts, etc. and at that point then allowed me to turn on the 240 volt inverter, and again go through its firmware updates and all that sorts of stuff. So everything's looking good there now. The only thing that I haven't seen active yet is the battery balancer, and having had a look at the manual, it is connected up correctly, and it doesn't kick in until I think it sees 27 point something volts on the system. So it just remains in an off state until that voltage is achieved, and it needs to start looking at the battery conditions. So while I was setting up the load shunt, so the main system 200 amp load shunt, I did notice on there that both the voltage readings for the midpoint and the upper were reading the same voltage, and it kept throwing an alert that there was a battery mismatch. And after much head scratching, I thought it was maybe set to system voltage levels, etc. But it turned out that I'd put the auxiliary connection, sorry, the VBAC connection for the load shunt onto the negative terminal at the midpoint instead of the positive terminal, so it was still seeing the lower voltage of the lower battery. So I shut the whole system down again, took the connection off the upper battery negative, and moved the VBAC connection across onto the upper battery positive, and then turned all the system back on again, and it started reporting the correct voltage. So there was just a slight wiring issue there on my part. And yeah, so that's all the wiring on. Everything appears to be working, although the battery balancer hasn't kicked in and started to do anything yet. I did check up at its terminals up on the actual battery balancer unit that I can see the 0 volt, the 24 volt and the 12 volt on the system for the two batteries, which confirms that all the wiring's okay and all the fuses are healthy in the protection circuits for it. So the only thing left to do down here is I've got a bit of cable management to do with the earths, and so just tidy up some of these cables a little bit, but I'll do all that once I'm happy that the system's all working. As I say, now I'm just waiting for the sun to come up onto the panels so I can see what the voltage and the power coming off the panels is doing into the batteries before I consider the system complete. So let's head up into the observatory now, and we'll connect onto the various devices and just see exactly what we can see inside. Alright, so here we are on my mobile, so we'll connect up the Victron Connect, and if we go to the device list, which is the main home screen, you can see all the devices on the system. Let me move you out of the way, and yeah, down the right hand side we can see the status of all the Bluetooth connections for each of the devices, and then on the relevant devices you can see the current high level status. So for example, there on the battery sense lower and battery sense upper, we can see the battery voltages up to 14.2 and 14.5 volts. And down on the load shunt we can see the system voltage is sitting at 28.7, and there's currently 5 amps going into the system, and the midpoint voltage of the batteries is showing at 14.2. And then right down at the bottom of the list we can actually see the solar charger, and at the moment the panels are still partially shaded, but we are seeing a 28.7 volts coming off the batteries, and there's 167 watts of power going into the system with the 5.7 charge current, and you can see that the charging state is currently in absorption. So if we open up the actual solar charger, we can see here on the status page, yep, there's the 167 watts coming off the panels. The voltage of the panels is at 53.59 volts, and the current is currently sitting at 3.1 amps. and the batteries, their voltage is sitting there at 28.7, and the current going into the batteries is 5.7 amps, and the temperature is 26. And if we click across to trends, here the trends is currently set for solar voltage, but we can also add the power. So if we set the blue trend to power, we can see the trend for the current status. And we can also adjust the time of the trend. So here's the last 15 minutes, 30 minutes, and the last hour. There's the last 5 hours. So the sun came up round about, or the sun started to come up round about 5:30 this morning, and we can see the system started to get a bit of power, and the current slowly, the solar panel power, the blue line, slowly increased until such point that it started to charge the batteries, and the system under load voltage drops back down as it started to push the power into the system. If we look at AC inverter, so there's currently no power being drawn off the system, and that's why it sits reading 0 VA. And I can turn on, I've got one fan currently connected to the inverter just for testing. So if I turn that on, excuse the noise, we can start to see it's drawing power from the system there at 67 VA. So all good there. So we can also, for example, have a look at the charge protect. So this is the power coming from the solar panels going into the batteries, and you can see the load output is on. And if for any reason I wanted to shut the system down from the charge side of things, I can just switch that load output off, and that will kill that system. And we can see the various settings there for when the system will automatically shut down and restart if the batteries are being overdrawn. So it's currently set for 21 and 24 amps. Likewise in the load protect, which is on the DC side of the system, again we can turn on and off the load, basically killing all the DC demand on the system. And again, it'll automatically shut down the system if the battery's voltage gets too low. So I need to go and have a look at the battery specifications and see what the minimum voltage should be allowed on the system, and set that accordingly. And then the power supply unit, so there's obviously nothing connected that at the moment. So this is the 30 amp supply to all DC devices, and yeah, once I get that set up, we'll be able to start drawing DC volts directly out of the system. Now at the moment it's set for the default voltage of 12 volts, so it's down stepping the voltage from the 28 to 12, and we can set the output voltage on the system if I wanted to nudge that up a bit. As we discussed previously, as you put more and more system on there, it'll try and maintain that steady volts, but by adding that little bit of extra power in there within the limits of all the devices, then we'll get better torque and everything on the motors. Alright, so that is the basics of the system, and next we'll look at obviously starting to switch the power over from all my existing AC systems across onto the inverter, but I'm going to wait until I've got a full charge cycle on the batteries, just to make sure everything's looking okay before we do that. So we'll probably come back in a while. Alright, we'll catch you later. Okay, so we're back a few hours later, and made some further changes. Namely, the batteries have been through a full charge now, and the battery balancer even came on and started to shuffle some load around in the batteries, and now it's just sitting in the on standby state. So it's working and doing as it should. And the other thing I've done now, as we can see here with my extension reel, no plugs, so all the power now has been transferred across onto the sockets that are fed from the inverter. So everything within the observatory now is being fed from the solar system. So the panels are sitting in full sunlight. The battery charger is, where is it? Here we go here. The MPPT. It's feeding around 6 amps into the batteries, and the batteries are currently in the float charge state. So everything's looking good there, and it's just drawing as much power as it needs off the solar panels. So nothing is being consumed by the batteries, and we're just floating the batteries and taking all the power being used for the observatory direct in off the solar panels. And we can see here on the Victron Connect app that so far today the panels have yielded 1.5 kilowatt hours of total power. So everything's looking good there. And if I hop across to the AC inverter, we're currently taking 145 VA of load over onto the AC system, and everything is working absolutely no problem at all. So the batteries themselves, the lower battery is sitting at 13.66 volts and the upper battery is sitting at 13.76 volts. So everything is looking pretty good. So we'll just have to wait and see now what happens in terms of how much load is consumed by the observatory once the sun goes down, but I suspect that we'll have more than enough capacity in a 24 volt system with 200 amp hour batteries in the capacity. So on that note, this will bring conclusion of this part of the series, and in the future parts I haven't decided what way I'll go down next, but I suspect I might go down the Servo GX remote monitoring, and obviously the phase 2 power, and then I will start looking at starting to move some of the DC loads off of the AC system and getting them directly wired into the DC loads. So on that note, thanks for watching. If you have any comments, questions or queries, don't hesitate to put them down in the comments section, and don't forget to like and subscribe, and obviously look forward to feeding back any of your comments and questions, and we'll see you in the next update, whenever that will be. So thanks for watching, clear skies everyone, and we'll catch you later.